Welcome to this ATA Insights webinar. Thank you for your ongoing interest and support of our webinar program. Today's session will begin in 2 minutes. ATA Insights Webinars is an online platform for the dissemination of professional renewable energy knowledge across international borders. Our aim is to democratize access to information, for innovation to spread faster, and to make the industry more competitive. And we do this through our online sessions, open to all our members. Every year we do more than 100 sessions with over 250 speakers, 50,000 attendees from more than 50 countries. To participate in the session today, use the chat on the right-hand side to introduce yourself, your company, and where you're joining from. Under the screen you will find the Q&A box, where you can send your questions for the speakers. We will get to as many as we can today. We're recording this session and we will send you a link to the materials in a few days. Please consider supporting our content creation for the webinar program. Contact us on the email on screen.
Hello, good morning or good afternoon, depending on where you are connecting from. Welcome to this ATA Insights online session. So today, as you can see on screen, we'll be talking about how to optimize the design of your photovoltaic plant to increase its performance and reduce operating costs. So we have three experts here in the I was going to say in the studio, but not quite, but yeah, in the webinar with us. And well, it's your chance to learn from them and ask questions. So I just want to remind you, as you saw in the video, that it'd be good if you could introduce yourself using the chat function on the top of the screen, and also that we are recording this webinar, and you'll get the recording in a few days. Right. So before we actually start, I'll ask our panelists to introduce themselves in the order in which I see them on the right-hand side on the camera. So the first one I see there is Germán. So Germán, if you could please briefly introduce yourself, that would be great.
Hello, good morning, good afternoon. Thank you very much to everyone for the opportunity to participate in this webinar. Well, my name is Germán Amores. I'm from Seville and Spain. So I have 14 years professional experience globally, and since 2010 I'm involved within the generation sector. Currently, I'm working in Engie Spain, so I'm in charge to the technical topics, so engineering tax within the business unit of renewable area. Within the Engie Spain, I'm in charge involved in the all technical topics, so engineering topics, so for the photovoltaic power plant in the country. Thank you very much.
Thank you very much, Germán, and very welcome to this session. So next, I'm going to ask Matias. Matias, if you could introduce yourself, please.
Hi, everyone. Thank you for joining. Good morning or good afternoon, depending on where you're joining from. My name is Matias Yudelevich. I'm the Product Marketing Manager for Europe, the Americas, and Africa for Ecoppia. I am based in Ecoppia's headquarters in Tel Aviv, Israel, and I'm originally from Santiago, Chile. Nice to meet you all, and I hope you enjoyed this webinar with us.
Thank you, Matias, and thank you for being with us today. And then, well, last but not least, Enric, if you could please introduce yourself.
Hello, good morning, everybody. Thank you, Carlos, and thank you to ATA Insights for this beautiful webinar. Well, my name is Enric Iñiguez. I am also from Spain, from Barcelona, but I'm based in Madrid. I have been working with Enel for almost 3 years. And currently, I am the area leader of the Solar Center of Excellence, which is basically the department charged with the evaluation of the PV plant designs in Spain and Portugal. So thank you, everybody, for being here, and I hope you have a very good time.
Great. Thank you very much, Enric, and welcome to the session. So I'm going to stop sharing my screen now, and I am going to open the floor to you. I believe that you are the first speaker, right, Enric? So whenever you're ready, start sharing your screen and begin your presentation. So I can see that, you know, lots of people are connecting from all over the world. So it's very, very good to see you all here, to everyone who is in the audience. So, you know, sharpen your pencils. So, well, you're not penciling anything, but, you know, like listen to Enric and to all the speakers and prepare you to send your questions through the Q&A box, and we'll get to them at the end.
Sure.
So, Enric, over to you.
Yes, can you see my screen properly? Can you hear me? Everything is working fine?
Yeah, I can see the screen. Yeah.
Perfect.
I can see the screen well.
So let's start. Well, first of all, of course, again, welcome everybody to this webinar. It is, of course, my pleasure to represent Enel GreenPower among all the colleagues of this interesting, challenging, and ever-growing field, which is photovoltaics. Well, I have presented myself, but I will present myself again. Quick word first about me. I am Enric Iñiguez, come from Spain. I have been working for Enel for 2.5 years now, involved in the Solar Center of Excellence department. Enel GreenPower is a very, very big company. We are present in more than 25 countries. We have more than 54 gigawatts of renewable capacity around the globe, and around 8.12 of those are solar energy. Specifically, in Europe, we have 1.31 gigawatt of solar capacity, currently between Spain, Italy, Greece, Romania, and Germany. And upcoming projects are being developed also in France and Portugal. So we have broad experience in the market, and we are constantly pushing to be in the front lines regarding technology, design strategies, and performance evaluation. Said this, let's get the thing out of the way. Photovoltaics is not rocket science, but there is a big difference, and especially in utility plants, between an okay design and an optimal design. Building a photovoltaic park is a conjoint effort of various engineering disciplines, which have to work in tandem to reach a common objective. Also, we should never forget that photovoltaics as a source of renewable energy should always be respectful with the environment and adapt itself to the reality of the site, trying to impulse sustainability and green solutions wherever it goes. That is why I like it so much. And that is why I have chosen actually this picture of one of our Spanish plants to start this short presentation, because for me it symbolizes the sustainable future and our symbiotic relationship with nature. But now let's get into it, okay? What is an optimal PV plant design? Well, sorry. There are a lot of markers that can be used in order to compare different systems, of course, but the chosen market in the field is the levelized cost of electricity, or LCOE, over another ones like cost per watt, for example. This kind of easy to understand marker is very useful as it serves to compare even systems built with different technologies. It will give us a value of currency per unit of energy delivered. So this way, it is easy to understand. If you sell the unit of energy at a higher cost than your LCOE, you will have benefits. In other words, it's what it costs you to create a certain amount of energy. I am completely sure that you have seen this graphic or similar 1,000 times before. But what is a photovoltaic webinar without it? So, well, here you have it. As you can see, the LCOE of PV systems has been reduced by a huge percent during the last years. And to what do we owe this reduction? Well, most of it, of course, is in the prices of the equipment themselves, but also the increased efficiency of the technology and the improved knowledge about PV design. And is in this last part what I want to face today, thanks to all the colleagues involved also in this webinar. Said this, let's get a little bit into action. How can we optimize the design of a solar PV plant based on reducing the LCOE as best as we can? Most of the decisions we take during the preliminary design phase can be represented by this simple image, a balance. We want to keep this balance, this perfect harmony between an efficient project in terms of energy production and an economically viable one, reducing the capital investment and the operational costs. Sometimes the proper balance is outside what we consider a good design or an optimal design. So how can we determine which is a good or a bad decision? Again, comparing the LCOE of all the presented cases parametrically, if possible. We, in Enel GreenPower, most particularly in the solar center of excellence, follow a set of steps which allow us to design the system the best way possible, always with the support of our internal LCOE evaluation tool, which is capable of efficiently manage different phases of the project to have continuity and flexibility in all cases. The points I would like to particularly pinpoint are the following ones. First of all, site evaluation and technology assessment, where we will evaluate the reality of our geographical, technological, environmental, and legal context to start presenting a set of constraints to the tool. Secondly, key configuration parameters, where we will set the most important factors in terms of preliminary design. After those, we will get the first energy assessment and basic configuration of the plant, and we can obtain a preliminary bill of quantities and layout. Third, final equipment selection, where we can input the current available offered equipment in the market to recalculate, based on the preliminary configuration, of course, a final configuration and energy assessment of the plant. Our tool will automatically tell us which combination of equipment is the most feasible. And last but not least, performance enhancers and intelligent solutions, other design strategies that I will briefly mention afterwards and can be implemented at any point during the design phase. This is why I have shown here 4 different arrows relating these ones to the other. At this point, I would like to mention briefly that we are talking about preliminary design. So from the early development of the plan to the final basic design configuration to deliver, for example, to the BOP contractor, who will perform the detailed engineering to bring our vision to reality. Site evaluation is crucial and needs the feedback of a lot of actors and disciplines, especially civil, environmental, and grid connection specialists. In this phase, we will select the best technology for our PV plant. It is very important to properly evaluate the topography, the water courses, and inundation risk. Also, to select a good meteo and solar resource data provider, as it will determine the quality of our assessment. It is imperative that we are aware of the variational nature of the global irradiation measure and to select a TMY, or typical meteorological year, which reflects the reality of our region. In parallel, once we have understood the requirements of the grid and the access capacity, we can start sizing our plant. We will select a preliminary module and inverter based on the observations we have made before understanding the state of the market. For example, if my terrain is segregated with very small areas and I need to maximize DC capacity, I will probably go for string inverters. If I have broad area with homogeneous terrain, I will probably select a centralized inverter preliminarily. My selection of tracker or fixed will come from the topography analysis of the site and the amount of power I want to install in the plot. Also, it is very important to know the legal frame of the region, as many of the administrations have particular sets of rules and constraints when it comes to develop PV parks. So at this stage, it's important not to hurry and to understand as much as possible as you can. As I said, the context is vital. There is no such a thing as a preset PV park. Once we have selected our preliminary set of equipment and we know how much power we want to install, now it's time to play with the 2 most important parameters in plant configuration optimization, the GCR and the DC-AC ratio. The GCR, or ground cover ratio, is the measure between the length of the structure and the pitch of the PV park, and it represents the amount of terrain occupied by PV modules. A higher GCR will allow you to reduce shading losses and improve the backtracking capabilities of your tracker. But, of course, higher GCR mean more deoccupation, higher cable quantities. So here we are already finding this balance I was mentioning before. We will optimize GCR according to the lowest LCOE figure. This is a study which was made for a particular plant. As we can see, the optimal GCR value was between 3 and 3.5. Nevertheless, normally we don't reach these values, as the aim of the company is also try to deliver as much power as possible. In the end, a bigger investment, though less efficient, can mean bigger benefits. The DC-AC ratio is another one of the important markers which can greatly change the LCOE of your project. It stands for the ratio between the peak power in modules and the active power of the inverters in the plant. If we, for example, aim for a ratio of 1, trying to get until the last drop of power from our arrays, we won't ever fill the inverters, as the losses in the array will reduce the total power and make it smaller than the nominal power of the plant. Also, year by year, the modules will be degrading, which will decrease even further this power. Said this, why spending money in inverters that we will hardly use, no? On the contrary, having a very high ratio can and will actually provoke the increasing of clipping losses. Clipping losses is the phenomenon that happens when the power that would be produced in the maximum power point by the array is higher than the maximum power available by the inverter. The inverter, of course, will not be able to work under these conditions, and potential power will be lost, as seen in the graphic I'm showing. A little bit of clipping losses is acceptable. Too much, and it can break your design apart. So it is important to always be in the minimum of the curve. To set the configuration of the plant using the inputs we have presented, we can, in our case, start the layout research algorithm. This calculation will explore as many possible system configurations, admissible, of course, within our constraint boundaries, which are the following: maximum and minimum DC capacity, maximum and minimum AC capacity, maximum and minimum DC-AC ratio, maximum and minimum GCR, and of course, a lot of more important information about the site to be able to determine, such as soiling losses, interconnection line losses, number of modules per string, area occupation of the plant, etc., etc. I will show you a real case of one of our projects in Almeria in Spain. We will call it Project X. This is a 250 megawatt peak project, and it is being designed using monoaxial trackers and central inverters. For this project, the tool was capable of analyzing and comparing a total of 231 scenarios parametrically. Each one of these points corresponds to one of the analyses. As you can see, there is a line which represents the optimal case. So this is where the point with the lowest LCOE is found. In this optimal case, for this calculation, corresponds to the values of DC-AC ratio of 1.17 with a GCR of 2.55. Well, a GCR in this case is the inverse of the GCR, of course, for clarification. The algorithm then will start to evaluate different cleaning strategies and frequencies along the years to finally give us the best LCOE possible scenario. So this is why you see in the line that the points are moving down. The tool is also able to generate a preliminary layout for us with an electromechanical and civil bill of quantities. At this phase, this can be very, very important if you want to launch a tender of BOP contractors, for them to have a clear view on what is our vision for this project. Remember that we are not yet doing detailed engineering. We are still in the preliminary design phase. In this layout, all the tables are represented. Internal roads and trenches paths are designed preliminarily, as well as the placement of the CUs and facilities of the plant. The tool is also able to calculate by itself the amount of earth movement based on a digital elevation model. In the end, a visual representation of the plant design is always welcome to corroborate your configuration, of course. Sorry. Then we can move to the final equipment selection. Again, how can you understand which are the best combination of module, inverter, and trackers for you? You can, of course, and as we have already done, evaluate the certain technology strategies, but each manufacturer is going to have a particular price. To evaluate this, we can again be helped by our tool. Once we have input all the equipment we want, the tool will generate the optimal configuration for each of the equipment's combination. Then it will generate a template where we can change the unitary prices of the equipments themselves and get a ranking of the best LCOE scenarios for each of our plans. So as you can see, we are completely covered in the preliminary design phase, from the site evaluation to the main configuration parameters, and then to the final equipment selection. Last but not least, I am going to briefly comment some of the performance enhancers that we are investigating today. The first one is robot cleaning, which fortunately will be explained much more in depth by one of my colleagues of Ecoppia. But basically, allow us to reduce soiling losses without increasing the OpEx too much. We actually have been purchasing this solution in some of our plants, and we are waiting for its results during operation in 2023. Second option is albedo enhancing materials, which were analyzed by us some years ago and had proven too expensive at the moment. The geolayer was not giving us enough boosted production for its cost. But now new and cheaper materials are around and we are investigating their behavior. Bear in mind that these materials will also change the bifacial production of your plant, so having a good bifaciality model is imperative. Also, and as I have said before, not everything is levelized cost of electricity. Sometimes it is important to take profit of the area and the reality of the world surrounding you. This is why I want to emphasize this, not new, but always challenging and changing PV applications, agrivoltaics, photovoltaics, and hybrid systems. All of these three will have growing importance in the future as we run out of usable area or we reach a point in where we need more agricultural area, for example. The possibilities are immense and beautiful. And I really think it is important for all the developers to adapt their methodologies and learn these new paths for better designs in the future. Thank you very much. You can contact me, of course, for any question or technical doubt you may have had. I hope you enjoyed this very, very short presentation. And thanks to ATA Insights also for organizing these sessions. And see you, colleagues, on the other side. Have a good day.
Thank you, Enric, for your presentation. So we already have like 9 questions on the Q&A box. So, you can answer some of them in writing if you want. Well, now I'd like to give the floor to Matias, who is our next speaker.
Perfect. Thank you very much once again, Carlos, and everyone for joining us in this webinar. So give me 1 second, I will share my screen.
So I see that a few people have asked, so we'll definitely be sharing the slides and the video recording with everyone who signed up to this webinar. So, just a reminder. So, Matias, I can see your presentation, so over to you.
Perfect. Thank you very much once again. So we are Ecoppia, as I said before. My name is Matias Yudelevich. I'm the product marketing manager for Europe, Africa, and the Americas here at Ecoppia. Let's say in complement to the presentation that Enric just made, I'm gonna target from our side, which is the O&M side, and specifically speak about the role of O&M in the design stage to secure profitability of the plants. So first, a little bit about us, very shortly. We are the pioneers and leaders in robotic automatic cleaning in a dry form. We have much experience and reliability. We have been in the market for almost 10 years. We have almost 4 gigawatts of projects deployed in 4 continents. So we have the experience and obviously the proof to show and back the concepts that I will share with you today. So first of all, I want to talk about the challenges of scalability. As we can see in this graph, we have had in the last 11 years an average capacity growth of almost 450% when we look at the average of each project. This is obviously based only on projects above 20 megawatts, as we focus solely on utility scale sites. So this obviously poses a challenge when it comes to the management O&M of a plant, right? Because we're talking about a tremendous amount of space, tremendous amount of rows, which is more challenging to manage. As well, we see here that the solar energy space is changing. We, as Enric also spoke about, this is, I think, the most heated topic in our industry right now is the record breaking of tariffs every year. We have seen a decrease of 86% in the tariff being awarded. And this is mostly because of some good reasons, right? We can see that many governments are either scrapping or decreasing the subsidies for solar energy. There is more competition. There is less land available. And therefore, we have seen with the grid parity on the photovoltaics that, as I always said, solar energy is no longer a non-conventional renewable energy source, but it's just a conventional renewable energy source. It's widespread, and we can see many countries where already solar energy composes more than 50% of the overall energy production. So this translates into several challenges, obviously, for the developers and asset owners. First of all, is the fact of the dilemma, right? Where we have the importance to optimize the plant so we can increase performance, but guaranteeing the stability and profitability of the plant. So as the capex increases, site owners face this specific dilemma. We have decreasing margins, and therefore we need to optimize the capex in order to make the site profitable. Unfortunately, in many cases, as we see on the ground, this comes into a detriment of the quality, as many times we see savings in infrastructure, equipment, and installation. As we can see also in the graph, on this banner that we made here, our approximate capex for several of the projects that we've been working for in 2021 was around $700,000 per megawatt. And in this sense, obviously, when we decrease the quality, it's very hard to keep the stability and performance of the site throughout the PPA of the plant, which could be 20, 25 years or 30 years. In this sense, we not only need to target the capex for the optimization of the plant and to keep its profitability, but also it's very important to think about the value of the asset. As they all say, says cheap is expensive in the long run, and we need to take measures in order to keep the profitability and performance of the plant, taking into consideration always securing the lifetime value of the plant. So thinking about the 20 to 30 years ratio in terms of maintenance and performance of the plant. And this is something that we need to consider beforehand. Okay, so therefore in the design stage of the plant. So which are the considerations nowadays in rough terms that are being weighed in terms of design? We can see that the bulk of it, 90% of it, is obviously most of the things that Enric mentioned, as topography studies, legal compliance, accessibility, irradiation measures, and so on. And only 10% of the considerations are operation and maintenance, okay, which is obviously the sector that we worked on, and more particularly in soil management, okay. Soil management, why it's so important, as we can see here in this example from arid regions and semi-arid regions in a study conducted by Darcy Partners, they find that almost 40% of the cost of O&M goes to cleaning. Therefore, optimizing cleaning solutions is paramount in order to lower the cost and increase the performance and profitability of the plants. Now, for the design stage, we need to consider the different requirements between different cleaning systems that we have, right? We need to first consider which is the adequate cleaning solution, right? And each one of them has different needs and considerations. Many times, and as we can see in Europe and across the world, the traditional way of conducting solid management is through manual or semi-automated systems, which could be squads of manual cleaning, could be an hybrid system using trucks or tractors, or also portable robots, which obviously needs to take into consideration pathways for the trucks to pass, water availability, different rows and quantity and dimension of rows, and the water infrastructure that we need for the manual and semi-automatic cleaning. And on the other hand, the considerations that we need for automatic cleaning, which I'm gonna address more in depth in the following slides. Now, I want to also emphasize one of the main considerations to choosing automated cleaning instead of manual and semi-automated, it's the frequency of cleaning. Okay, as we can see on this graph based on our experience, when we have manual cleaning, usually it's made in cycles, right? Depending on the soiling loss of each plant, we can see whether we have clients that in the past used to have 3 to 5 to 12 cycles of cleaning a year, depending on the location. And here we can see that obviously after you clean the first few days, you will have 0% or marginal energy loss due to soiling, right? But as we move forward throughout the month, and also several months, if we have only, let's say, 5 cleaning cycles a year, we can see an exponential increase in the percentage of energy loss. So that's why when you have an automated system that cleans daily or every other day, we see a dramatic decrease in that energy loss. As we can see here, when you clean daily, you can have up to only 0.3% of energy loss. So that's why it's very important to clean with an automated system, and that's why we believed in that way of cleaning, and that's why we focus solely on automated solutions. Now, there are several actions. The importance to proper design for soiling management. Okay, as I said before, nowadays, even though this is something that is increasing, thankfully, there is not much attention put in the design stage to soiling management. And there are several considerations here that are very important. First of foremost is the site complexity. As Enric also mentioned, there are a plethora of different considerations that need to be attended. And in this sense, we need to perform the right measures to optimize the design. Right, one of them of these challenges is the site complexity, whether it's topography, slopes, tolerances, etc., and as well the impact of rows and orientations, whether we have short rows, as we can see on the example on the left, or longer roads north to south, as we can see on the right-hand example, as well as their orientation. And in this sense, according to our experience, whenever you have an optimal design, you can see a decrease of the cleaning costs to up to 50%, which obviously is very, very impactful when we consider the low margins that we are witnessing in the industry. I just want to give you an example from the ground of one of our projects where we were involved in the design stage. Obviously, this is very important to emphasize as well that all of this is made in alignment and close cooperation, both with the site owner and the developers, and also the EPC contractor, in order to really align all the needs and considerations of each player and be able to come into an agreement of what is the most optimal for every aspect of the plant. Right. So here we can see that with our input on the upper image, the gap between the rows was of approximately 4 meters. And for us, we deem as an optimal gap between rows in order to be able to create bridges between the rows in order to minimize the amount of robots per megawatt of up to 2 meters. Here, we were able to decrease the gap to 1.5 meters, which led to a reduction of 40% of units required in the site, therefore dramatically decreasing the capex of the cleaning solution. Which are like the considerations for automated soiling management. At the end of the day, the main mantra here that we need to take into consideration throughout the decision-making process is to lower the cost per megawatt, right? To increase, obviously, the profitability of the site. So which are the important elements and benefits when included automated soiling management in design? First and foremost is the layouts, right? We want longer roads with no obstacles. Therefore, we optimize the cleaning coverage per road. For example, our latest solution, which is the A4, can clean up to 1 megawatt per robot. But this obviously needs to be done with the proper layout on the ground. Therefore, we need longer rows in order to be able to maximize the performance of the road. On the other hand, as well, when we decrease the gaps, as well between the tables, we can decrease up to 40% the cost of materials, which is auxiliaries. We're talking about bridges, docking stations, so on and so forth, that we need implement our solutions. And this obviously has an incredible impact on the capex of the solution. And last but not least is the optimization of real estate utilization, right? The owner of the asset has a limited space, and every square meter in this real estate matters. So therefore, when we optimize the site and we decrease the paths and we eliminate considerations that will require a lot of land, which is, for example, the manual solution using tractors, for example, we can optimize the facility and land use for other purposes. Now, integrated design stage at the end of the day, when the whole PPA period and O&M is considered, has a lot of benefits. On one hand is the long-term view, right? As we mentioned, one of the most important things is to consider the whole PPA of the plant when we design the plant, and not just the reduction of capex. On the other hand is the implementation of new technologies. At the end of the day, the solar energy industry is always striving for new innovations. And therefore, when we have an integrated design stage, we can apply these innovations, whether it's from monitoring, soiling management, or other innovations that we have in the industry that will, at the end of the day, increase the maximize production while increasing also the profitability. And the other aspect as well is the tool to provide the asset managers to monitor performance at the end of the day. And this is feedback that we have from many of our clients. Many times the clients run blind when it comes to soiling management and measuring the soiling loss and the efficiency and efficacy of their cleaning solutions. So in this sense, we can provide as well with our BA and our recollections of millions of data points, all of the inputs and insights that the site owner needs in order to manage and measure this impact. Now, there are many defining factors that we need to consider while choosing a soiling management provider. And these are certain things, obviously, that we can provide, and we're very sure, based on our experience, that we can provide this uniqueness and versatility. And as I said before, the most important is the implementation of these solutions and see the impacts of soiling management and not just the theories made in a lab. As we can see here, we have vast experience with different kinds of soiling. As I'm pretty sure my colleagues are aware, each location has different soiling. Each soiling particles has their own challenges and particularities, and therefore you need to be able to tackle each kind of soiling in an efficient and an effective way. Sorry. So why we are able to tackle all kinds of soiling? Because we have a global footprint, right? We have operational and awarded projects in more than 4 continents, as we can see here. As well, we have offices in South America, in Europe, in the Middle East, and in India. And as well, something that's very important is the adaptability to diversify, right? Understand that every site is different as well. In our industry, it does not exist the model of copy-paste, right? We need to closely understand the challenges and particularities of each site separately, right? And that's why we have a state-of-the-art facility, as you can see here on the left-hand side, when we consider every eventuality for maximum performance throughout the duration of the PPA of a plant in a singular manner. That's why we have simulators of leading trackers and structures, models from leading model providers, frame and frameless, and where we perform V&V tests, acceleration testing, load analysis, destruction tests, and maneuverability, so we can see on real time the impact that we have in the soiling management and our adaptability with the different providers. As our industry grows, we have ever appearing new providers of every aspect and angle of the industry. So in short, why involve Ecoppia in the design stage, right? As we can see before, soiling management, even though it's something new that is coming into into consideration. Beforehand, many of the developers will take the loss as just something that they need to cope with. We're going to lose 5% in soiling, and many times their models were based considering the loss. But now with the decrease in tariffs, obviously this is very important to consider every single margin, and therefore there are a lot of new players coming up with soiling solutions. But why to consider Ecoppia? First of all, is the reduced cost. We, as a dry cleaning solution, we don't need water infrastructure. We don't need water or labels. So in that sense, we neutralize those variables for throughout the PPA of the plant, and as well no escalation. Our OPEX is a flat OPEX, where whatever you pay on day one is the same money that you pay on year 20. On the other hand, is the added value that we provide to the plant. Optimal year-round production and performance, as I mentioned before in the graph of soiling of power loss, right? We do not clean on specific cycles a year. We clean year-round, therefore maintaining power performance of the plant. And therefore, we maximize the profitability, we lower the cost, and also maximize the production. And of course, something else that I mentioned before, real estate is an ever decreasing commodity. Therefore, it's very important to be able to optimize the land use, and therefore by implementing an auto-managed solution, we can allocate that real estate on a more efficient way. So thank you very much. And if you have any question, please address it in the Q&A, or obviously after you can also contact me, and I will be more than happy to answer your questions.
Thank you, Matias, for your presentation. So yes, there are quite a few questions addressed at you actually in the Q&A box. You can start answering them if you like, and we'll definitely comment some of them, because there are some recurring questions on the kind of tools used for all of the simulations, and the use of they call it the use of material albedo enhancing materials. And yeah, we'll cover those in our at the end when we go through the questions. But now I'd like to give the floor to Germán, who is our next speaker.
Okay. Hello to everyone again. Thank you very much again to join this opportunity. I'm going to share my screen here. Wow. Can you see my screen?
Yes, I can see your screen. It's on full screen, so great. Over to you, Germán.
Perfect. I activate the pointer laser. Okay, so, well, I try to base my presentation in this main block, okay, which according to previous Enric and also Matias experience is quite similar on the same line that they have mentioned previously. In the design process, try to obviously to improve the LCOE or the optimize design of the power plant. So, well, the first step that we consider according to our experience obviously is the site condition, the specific, and obviously solar resource. Probably obviously the regulation, local and international regulation that we need to consider, and for sure possible client requirement that we need to obviously to consider. And the main block that we consider that iterative process within the optimization of the power plant. We have a main block with obviously we need to decide according to this main input to well, with the proper equipment that we need to select, and after that to perform the layout configuration. We need to decide about the DC-AC ratio, about the pitch or ground cover ratio, about the BOP configuration, electrical configuration, number of combiner boxes, routing cables, trains, routing, etc., etc. Obviously, operational strategy in turn to OPEX cost for the LCOE or for the project. After that, we have the proper inputs in terms to yield evaluation, CAPEX and OPEX, and this point can to be obviously or can be output and for all financial model in terms to evaluate at the end. So the profitability of the project globally, and when we conclude with the financial model evaluation, start again or to provide feedback again to this main block in there to review again the solution and probably modify something in there to at the end to get the optimal configuration in this iterative or global process. For the main input, as we commented previously, well, the main topic of the geotechnical issues, the environmental, topographic, hydrologic, site access constraint, for sure, grid code constraint that we can find, weather condition, etc., etc. And additionally to the project site specific, obviously the solar resource is other main topic because it is a global radiation, the latitude in which we are going to install the project. Additionally to that, so according to these main inputs, we start with the iterative process with the first block. I mean, this selection of the main equipment, layout, and operational strategy. Obviously, for the selection of the main equipment, we have mentioned previously, we have obviously the PV models. If we are going to select the monofacial or bifacial solution, according to obviously the site condition of the weather, in which obviously we are going to select bifacial solution, we know that we can have also impact in the structure solution, and for sure in the operational cost, because we need to have the cleaning of the grass of the terrain in order to obviously to have a good reflection. So it's other big point to have into consideration when we are going to select a bifacial solution in order to to secure the albedo along a complete year. Well, currently we know the most common solution in the commercial solution in the market is a mono pair solution, okay, mono bifacial, and in the inverter for sure the dichotomy. If we are going with central inverter, when it's inverter. According to our experience, central and string inverting in terms of capex is around quite similar. Okay, currently, obviously we have or we can detect a significant impact in the OPEX. Obviously, for the difference between the string and the central, the string is more cheaper in terms of OPEX. Obviously, it's more easier than the central inverter, and for sure about the availability of the power plant. Is obviously because we have significant impact if we lose a central inverter with 4 megawatt in the power plant. Instead, if we lose a single or two string inverter with 200 or 250 kVA. It's clear. About the structure solution, we have two main, obviously, also dichotomy. The stick structure of solar tracker. The difference is in impact in yield. So we can have between 10 or 15% of differences between fixed structure solution and solar tracker. So always that we can, and the site condition permit go to the solar tracker solution. Obviously, we have impact in capex because solar tracker is more expensive, obviously, than the fixed structure, and the maintenance in opex is more expensive also. But I think that the impact in the financial model with the intent to yield impact with solar tracker is higher than the possible impact in CAPEX or OPEX. And the cleaning solution, also Matias has commented previously that we have the conventional solution, a tractor plus brush, or obviously the robot solution, which can have impact also in the selection of the tracker. We are going to obviously to select the robot solution. About the plant layout, as I commented my colleagues previously, the main input is the DC-AC ratio, obviously the pitch. When we select the configuration of this structure of solar tracker with the 1 view or 2 view solution, definitely the height of the structure, we can define properly the pitch and the ground cover ratio that we need. Important point about the pitch that we have a constraint. Obviously, the supplier of the tracker will say, okay, you have a maximum 15 or 14 distance between row of tracker, because obviously otherwise all tracker could be considered edge or external tracker. which could have a big impact in the capex also. So we have a discount trading pitch, always the maximum pitch that we have, obviously intend to improve the performance of the production. The EC/AC ratio, according to Engie experience or recommendation, is about 1.2, 1.5, always according to the constraint or limitation of the number of DC incoming for the inverter, okay, and the obviously the power of the inverter. As Enric commented previously, we need to avoid the clipping. If we increase much the DC/AC ratio, we have the risk to have a clipping in the inverter. So at the end, lose power and lose money, obviously during the operational of the plant. Always for the DC/AC ratio, we need to have in mind the grid code restriction. In turn to define the AC power at inverter level, we need to have in mind the grid code requirement. So in turn to reactive power capability, so we need to define how many megawatt in AC inverter we need at power plant, and according to this minimum, we can try to fix what is the DC/AC ratio. And obviously we have a maximum DC that is in the administrative process that we have declared to the administration. No? But this is important topic for the AC ratio, because otherwise we don't have sufficient power intent to comply with the capability of reactive power capacity at point of connection, according to the active power declared to the TSO, transmission system operation of the country. We need to install additional capacitor bank or stackon, which have impact at the end in the operational strategy of the power plant, OPEX, and for sure in CAPEX, because it's a device is expensive. No. For operational strategy, this is other. Probably it's not the key topic for this presentation, but we can go obviously to operational on a maintenance subcontractor directly, or we can have in-house human resource in terms to provide obviously this operation and maintenance tasks internally in the company, who have possible impact in OPEX costs. For operational strategy, for my side, the key topic obviously is what is the strategy with the supplier. So frequently, the most simple and in the commercial situation is go to to sign the LTSA contract, obviously with the inverter, with the structure manufacturer, and also for SCADA manufacturer. So okay, it's the normal solution at least in Engie philosophy. For operational strategy, also really very important, obviously, to have the sufficient information. Obviously, that previously we have a question about how that we can perform the detection of soiling, to obviously to detect how many cleaning cycle at the end we need to dedicate during the operation. The operation is we have a soiling station dedicated device to detect with the percentage of soiling, and for sure weather station and other meters, and a proper obviously monitorization level. Always it is possible for sure a dedicated tracker system monitorization, and for sure a proper normal solution for monitorization for inverters. And in turn to other big topic, this previous presentation obviously is in turn or regarding to this main key topic is a KPI point. So because this situation obviously can permit obviously to see what is exactly the operational obviously at the end of the power plant. I am showing only the main or one of the main performance radio, availability. Internally in Engie, we are developing a KPI strategy in turn to detect, because the key topic here is the power, the referent power or the referent energy, obviously, and in turn to evaluate the losses at the end in the power plant, and also obviously the unavailability that we have in the power plant. So the question is to evaluate when, for example, we have a 1 tracker or 2 tracker stop, try to perform how many megawatts or kilowatt hours we are losing due to these 2 stops to tracker stock. No, that is we are internally working in Engie Group to perform this dedicated or specific KPIs in turn to improve this information. After this first block, when we have, this selection of the main equipment, layout, and operational strategy, obviously we need to evaluate the CapEx, OpEx, and for sure yield. About the yield, I'm only showing the main points, so shading. Obviously, about the shading, only to comment that we have a PV case and LS3D currently intend to evaluate 3D shadows that we can export to PVCs in turn to evaluate with more detail the soil losses. The other key topic is about that point. I recommend highly that for this losses, the dedicated losses, we are not using directly the PAM file of the manufacturer. Now, if it's possible, use a third party, a certification entity like, I don't know, TÜV or Bureau Veritas or etc. In that they can provide a dedicated report about what is exactly the IAM losses for your PV module that you are using in your project. Here, LID frequently, for the normal or commercial solution with mono-PER, currently, according to our experience, we are going to use a minus 0.5% of LID losses. And about the soiling, which can obviously a really bad impact in the cleaning cycle and obviously in the OpEx solution. Here in Engie, we have a dedicated software in turn to evaluate what is the proper soiling ratio that we need to obviously to agree in the operation and maintenance contract. You can see here we dedicate the input, not only technical input, but also commercial input, in which we can evaluate with the percentage, the proper percentage according to the site condition in the project site. Here is only a breakdown that the different percentage of the different parameter of the yield evaluation, the losses, like I commented previously, LID, near shading for sure, DC and AC wiring losses. With the pen, obviously, we are going to a string central inverter or a string inverter, etc. So it's only ranks that we are considering within the company. And after the yield evaluation, I commented previously, CapEx and OpEx, and only brief information is a breakdown. That in Engie Group we are considering for the global project, not only in CapEx puntual. We need to consider obviously that development cost and obviously different contingencies, for sure provision for dismantling at the end of the life of the plants, 25 or 30 years, etc. Is only a brief breakdown intend to get the total investment cost for the project. When we have this first with the input, we have selected the main equipment, we have selected the layout, we perform the layout, the BOP level, we have evaluated the operational strategy, and we have performed the yield and the CapEx and OpEx. Obviously, we have the output to analyze in the financial model. Frequently, we use internal tools, Excel files, and normally we have a dedicated group with the Engie's Alpha, which are dedicated to analyze the financial model of the group, of the project, PV project planning within the group, and they have obviously take into consideration this main input, the timing of the project, obviously the operational assumption, CapEx, OpEx, etc. And after obviously this evaluation of the financial model, we can start again with this iterative process to optimize the design at the end. No? Thank you very much.
Thank you, Germán, for your presentation. So well, we have still a few questions. If you don't mind, we could stay for another 5 minutes or so and try to answer some of them. We've technically run out of time, but I think one of the questions I have is about the design stage. So, maybe Matias could answer these. Why is it important to get the company that is providing the cleaning services involved at this stage, at the design stage?
Thank you for the question. As I mentioned as well in my presentation, at the end of the day, there is a very considerable impact on the cost per megawatt of a cleaning solution of all kinds, right? Not only our automated systems when it comes to the design, right? Many times when it's not considered, we see many cases where it's impossible to implement an automated or even semi-automated solution due to the short rows, as well as the lack of optimization in terms of the gaps between the rows, that it makes it impossible from an economic standpoint to implement these solutions. So even though at the end of the day, as I mentioned, we have almost 10 years of experience, and being an established partner and player as well, for us, it's very important to conduct a very open and transparent process with our clients, right? We won't try to push a solution where we don't see there is something that makes also economic sense to the client. So in that sense, whenever we see an important discrepancy in the design, in the layout of the plant, we recommend not to implement the solutions because of the economic considerations. Therefore, it's crucial to include us in the design stage, at least to provide our input. As I mentioned before, there are a plethora of considerations that are beyond, obviously, soiling management that need to be considered.
Thank you very much, Matias. And the next question I have, well, the question that I see that Germán is writing into the Q&A box, but someone is asking whether there is a minimum number of megawatts per weather station, and how do you decide how many weather stations to install per PV plant?
Mm-hmm.
What are your thoughts on this? So
yeah, so we frequently use IEC rules. IEC, the IEC standard define the minimum number of weather station per megawatt. For example, currently we have a 50 megawatt under construction or under design, and we are going to install the only main weather station. But at the same time, we are installing the five dedicated pyranometer to be installed in the plant of the solar modules. So for 50 megawatt power plant. So it's more or less according to our experience, but always according to IEC standard for the weather station or pyranometer to be installed in the in the plane in order to detect the incident irradiation, and also according to install the minimum number of soiling station. Also, we use the IEC recommendation.
Thank you very much, Germán. And Enric, I don't know if you're a bit quiet, so I don't know if you'd like to add to this, or should we go to the next question?
No, actually, yeah, I think my colleagues have answered perfectly. And yeah, you can switch to the next question.
Okay, so I think we've actually answered most questions. There is one here addressed at Matias, is by Marco Malagnino, and he asks, how about humidity? How does humidity affect soiling? In which way do you avoid the cementation of sand and dust over PV modules? Do you have a specific cleaning strategy?
Yes. So in short, yes. I'm very happy to clarify this point. The best way on our strategy to avoid cementation and caking is because we clean over clean, right? As I mentioned before, we don't clean in specific sporadic cycles. We clean over clean, whether depending on many considerations that we analyze with the developer and the asset owner. It could be whether on a daily basis, every other day, or maximum, as we recommend, every 3 days. So in this sense, we are continuously removing the dust from the panels, and therefore we avoid any kind of cementation. And also, which is very important, that we do see with semi-automatic or even wet solutions that use brushes, we use microfibers, is that whenever you have cementation, in order to remove it, you produce abrasion of the panels. You degrade or even remove the arc from the panels, and creating hotspots as well, and micro cracks, which is obviously a major blow when it comes to both the health of the plant, but also its capabilities. So therefore, by cleaning over clean, you not only avoid cementation out of itself, but also the implications of removing cementation. And regarding to humidity in general, because we're a dry solution, obviously there are certain constraints, right? Obviously, when we put in a balance, which is the main motto here, right, about the opportunities that we need to consider. It's very important that even though there are certain constraints with humidity, right? Because if you clean on a dry manner on a very high humidity rate, then obviously you will submerge the soiling throughout the panels instead of removing it. So we do have that constraint that we clean. Therefore, as well, we clean nightly before the dew point in order to avoid that high humidity rate. But obviously, this is very important when it comes to cleaning, avoid smudging, and also avoid cementation.
All right. Great. Well, thank you, Matias, for your answer. I think last question, which is actually, the last actual question here is whether there is a significant difference in performance on when you compare portrait versus landscape installations, and which one would be a better option for a robot integration. I don't know if Enric, if you'd like to take this question.
Sure. Well, I will leave, of course, the part of the road clean to Matias. But when comparing portrait and landscape configurations, you should think about the type of module that you're using, and also the availability of the tracker manufacturers or structural manufacturers. So first of all, normally the main strategy for utility PV plants is the portrait configuration, because it's true that when using a standard PV module, it can lead to, for example, problems with the shadowing of the strings of the modules. But when using half cut cell modules, which are the ones that are being used now the most, this underperformance is mitigated by the independency of the two parts of the module. So it's better to put them in portrait. Also, from part of the structural manufacturers, it's easier to get portrait structures than not. The other part, of course, if you think about trackers, as you will have the backtracking algorithm, you should not be shading your model at any time, maybe at the first hours or the last hours of the day. So at the end, it's better to think about, okay, which structure fits the plant better, and it's cheaper for me, and not in terms of production, because anyway, probably if you use tracker, you won't have this problem, and if you use fixed, then you can have it, but probably you will be working with half cut cell modules, so you won't have this huge problem as well.
Thank you very much, Enric. I don't know if Germán or Matias would like to comment on this question.
I just have a very short comment. First and foremost, I agree completely with Enric's appreciations about this question. And I only want to add something very simple. At the end of the day, we provide a solution to site owners, not a hurdle. So therefore, all of our solutions are in tune with the needs of the clients, and as well as the trends in the market, right? So obviously our integration is in tune with what is being used in the market, and our R&D teams are always working towards that aim. So that's why we also concur with the Enric's appreciation, because we build our systems based on our clients' needs and not the other way around.
Thank you very much, Matias. So, well, unless any of you really wants to make a point now, I think it's time to bring this webinar to a close. Like all good things, it must also come to an end. So thank you very much for being with us today. We've had a great audience there. I'd like to thank everyone who's been with us during this hour, and of course Germán, Matias, and Enric for sharing your knowledge and your experiences with the renewable energy community. So we, as I've mentioned a few times, this webinar has been recorded. We'll send you, and when I say you, I mean everyone who signed up, the recording and the presentation. So thank you, and I really hope to see you again at other webinars that we have. So if you look, actually, I'll paste it really quickly here. So our website, where you could see all the webinars that we do, and the one thing that you don't know is that yes, you can sign up, but you could also find this recording and all of the other recordings that we have had on the archive that we have on this website. So well, without any more to add, thank you very much, and all of you, and have a good day.
Thank you very much. Nice day, everyone.
Bye, everyone.
Thank you.
Thank you.